Decimal degrees express latitude and longitude geographic coordinates as decimal fractions and are used in many geographic information systems, web mapping applications such as Google Maps, and GPS devices. Decimal degrees are an alternative to using degrees, minutes, and seconds. As with latitude and longitude, the values are bounded by a plus or minus 90 a degree and a plus or minus 180 a degree respectively. Positive latitudes are north of the equator, negative latitudes are south of the equator. Positive longitudes are east of Prime Meridian, negative longitudes are west of the Prime Meridian. Latitude and longitude are usually expressed in that sequence, latitude before longitude. Precision: the radius of the semi-major axis of the Earth at the equator is 6,378,160.0 meters, resulting in a circumference of 40,075,161.2 meters. The equator is divided into 360 degrees of longitude, so each degree at the equator represents 111,319.9 meters or approximately 111.32 km. As one moves away from the equator towards a pole, however, 1 degree of longitude is multiplied by the cosine of the latitude, decreasing the distance, approaching zero at the pole. The number of decimal places required for a particular precision at the equator is, a value in decimal degrees to an precision of 4 decimal places is precise to 11.132 meters at the equator. A value in decimal degrees to 5 decimal places is precise to 1.1132 meter at the equator. Elevation also introduces a small error. At 6,378 m elevation, the radius and surface distance is increased by 0.001 or 0.1%. Because the Earth is not flat, the precision of the longitude part of the coordinates increases the further from the equator you get. The precision of the latitude part does not increase so much. More strictly, however, a meridian arc length per 1 second depends on latitude at point concerned. The discrepancy of 1 second meridian arc length between equator and pole is about 0.3 meters because the Earth is an oblate spheroid. Example: ADMS value is converted to decimal degrees using the formula. For instance, the decimal degree representation for 38 a degree 53 a euro squared 23 a euro cubed n, 77 a degree 00 a euro squared 32 a euro cubed w, the location of the United States capital, is 38.889722 a degree, minus 77.008889 a degree. In most systems, such as Google Maps, the degree symbols are omitted, reducing the representation to 38.889722, minus 77.008889. To calculate the d, m and s components, the following formulas can be used. Where dd is the absolute value of dd, trunc is the truncation function, and mod is the modulo operator. Note that with this formula, only s may have a fractional value. Pseudocode, using numbers from above, $min equals int, mod, 38.88972260, 60. $sec equals round, mod, 38.889722 3600, 60 equals min, 53, sec, 23. References